guess this is part 2 all of a sudden. I wanted to hit autofocus and I just hit stop, but it is what it is. Part 2, it doesn't matter if the coefficient is a negative number. As long as the coefficient is an integer, I can solve by dividing. If the number in front of the variable is a fraction, I do something different, and that's going to come up pretty quick here. So in number 12, just because I have a coefficient or a number times a variable, the best way to isolate is to divide. And on the right-hand side, if I do 48 divided by -4, you can just enter that fraction on my calculator using the negative under the fraction. The left-hand side, the double negatives cancel, the 4's give me a 1. And on the right-hand side, I get what I believe is the answer, which is -12. I should always check. So the original problem was -4 times x equals to 48. I'm going to change the x to a -12. Because there's multiplication, when I'm doing that substitution, I'm using a parentheses just because it's the easy way to do multiplication. And on my calculator, I did the negative by the fraction, the 4, left parentheses, negative by the fraction, 12, right parentheses. And now this is going to give me exactly what I hoped for. I have a correct solution that 48 equals to 48. This is a deal. This is one of the big tricks. If you have a problem set up with a fraction times a variable equals a constant, then instead of dividing both sides by that fraction, we're going to multiply by the reciprocal of the fraction on both sides, because any number times its reciprocal is 1. So this is the variation. If there is a coefficient that's a fraction, instead of multiplying or dividing by that fraction, we'll multiply by the reciprocal. I can show you on the left-hand side what happens when I multiply 4/3 times 3/4. I can't show you with the y, but the number part of the left side is y. I technically get 1y, and that 1 is always implied. If I just write a naked letter, there's an implied coefficient of 1. I didn't leave myself room to write the 4/3 to the left of the 21, which I kind of wanted to do. But it doesn't matter because multiplication is commutative. It's not wrong to have that 4/3 on the opposite side. And let me be lazy here. I'll go 21 times fraction 4/3. Lazy and accurate and fast. I claim the answer is y equal to 28, and I should check because it's not that hard and I can check. So I'm going to go 3/4 times 28 using a parentheses because the y had a coefficient. I'm going to make sure that equals to 21. I'll do it on my calculator, then I'll show you a slick way to do it by hand. So 3/4 times 28. That gives me 21 equals to 21. If you're working by hand, you're allowed to reduce fractions by integers. The denominator of the fraction is allowed to cancel with that integer. So if I was free of my calculator, I could slickly reduce this. If you're kind of going high in math, it's good to be slick. If you're not going super high in math, being slick is not such a big deal. But by hand here, I could go this 4 cancel with this 48. 4 divided by 4 is 1. 28 divided by 4 is 7. And what this is going to leave me on the left-hand side is just 3 times 7, because the denominator of the fraction turned into a 1, so I don't need to write the denominator anymore. And then 3 times 7 is 21. Sixteen's kind of the same thing, but it has a negative, which makes it ugly. So I'm going to do the same thing. I'm going to multiply by the reciprocal. If there's a fraction in front of the variable, I need to multiply by the reciprocal. And we found reciprocals, in the last chapter. And when I was doing a reciprocal of a negative, it didn't matter if I put the negative in the denominator, in the numerator, or out front. Probably the nicest place to put the negative for algebraic purposes is probably in the numerator. And I'm going to do the same thing on the right-hand side. If I do something to the left-hand side of the equation, I have to do the same activity to the right-hand side. So on the left-hand side, what I have is negative 4 over 5 times fraction negative 5 over 4. That gives me a 1 in front of the x. Anytime you multiply by reciprocals, you get 1. And I'm going to do this right side by hand just to get you seeing it, but I'll also do it on my calculator. I'm going to take the 5 and the 30 and cancel. Fraction times an integer, you can cancel the denominator with that integer. 5 divided by 5 is 1. 30 divided by 5 is 6. I canceled the entire denominator, so that just leaves me negative 4 times 6, no fraction anymore. I claim the answer as negative 24. If I didn't want to do this by hand, I just could have did negative 4/5 and then times 30 either with a parentheses or with a times sign, and that would give me the negative 24. And I'm going to check. It's so much quicker to check with my calculator that I'm not feeling the urge to check it by hand. Make way less mistakes pressing buttons than anything. So let me check this. Fraction negative 5 over 4 times negative 24. And that checks perfectly. I get 30 equals to 30. There's a ton of problems in this section. So, and I already split part 1. I'm probably going to be 4 parts because this first part was so short because I messed up. You can get fraction answers to these, and this next couple I think are going to be fraction answers, at least this next one is. So I didn't leave myself room here because that 18 is so close to the fraction, can't solve it so nicely. So I just rewrote the problem to give myself some room. If there's a fraction in front of the variable, we're going to multiply both sides by that reciprocal of the fraction. On the left-hand side, when you multiply by reciprocals, you get 1. And on the right-hand side, if I'm not using my calculator, I'm thinking of 5/2 times 9 over 1. I'm just going to multiply the 5 and the 9 and get 45. I'm going to multiply the 2 and the 1 and get 2. But again, you're allowed to use your calculator. If you need to use your calculator, mostly your teacher's not going to know because most teachers would do this multiplication in their head anyways. So I claim that's my answer. I could check by hand, but it takes me, just a fraction longer to check by hand than it does on my calculator. And time gets to be important on tests, and accuracy gets to be important on tests. I think I'm as accurate or more accurate with my calculator, and I'm faster. So I'm going to check on my calculator. Not that I couldn't check by hand. Actually, kind of easy to check this by hand, but it checks just fine. For those of you that like doing it by hand, these 2's will cancel. This 5 will cancel with the 45. I'll go 5 divided by 5 is 1. 45 divided by 5 is 9. The entire denominators are gone, so I don't need a fraction, and the only thing I have left is a 9, so it equals to 9. That's not a stellar explanation, but that's just a quick explanation for those of you that are wanting to do things by hand. So problem 20, I have to multiply by the reciprocal to get the variable isolated. And because it's a negative, I'm going to put the negative in the numerator, so I'm going to multiply both sides by the reciprocal of negative 4/3. And I have flexibility in terms of where I put the negative sign. I like it better in the numerator. On the left-hand side, I'm multiplying reciprocals, and reciprocals always multiply out to be 1. I don't need a number in front of the x. On the right-hand side, I'll probably just use my calculator, but I can quickly do this without a calculator. Without a calculator, the 4 cancels with the 20. The 4 becomes a 1. The 20 becomes a 5. It makes the fraction go away. And then either with a parentheses or a times sign, what I'm left with is negative 3 times 5. The answer is going to be negative 15. And again, on the right-hand side, I just needed to do that multiplication. I could use a times sign, or I could have put the 20 in a parentheses. I claim that's my answer. And usually, if I'm checking, I don't even write down the checking. I just do it on my calculator, just because this process of writing down what I'm checking, it's taking time. And if you're slow and time is precious, I would have just entered this on my calculator. Do negative 4/3 times, either with a times sign or with a parentheses, negative 15. And in my head, I would have just had this all done in my head and had a virtual check mark as opposed to a physical check mark. You don't have to write down the checking if you're checking on your calculator. And if it's a simple-ish checking, then it's okay to check virtually or on your calculator, not write anything down. So the next few problems have both skills. I need to be able to subtract a number and divide. And when it's the case where you have a number multiplied by the variable and a number added or subtracted to the variable, it's kind of reverse PEMDAS. PEMDAS, you do division before addition and subtraction. Solving for equations, we're going backwards. We're going to do the subtraction and addition or addition first, and then the division or multiplication second. So first, for problem 22, I need to get the constant by itself on the left-hand side. Just like I did for the first few problems, if a number is added, I subtract it to get it to the opposite side. If a number is subtracted, I add it. This is kind of violating PEMDAS, but there's new orders of operations for solving equations. So cancel out the 18s. 38 minus 18 is 20. And now I have a problem that's like the last group of problems. So this is a combination problem. It has both skills that we've learned so far. I'm going to divide both sides by 5. And I'm going to get x equal to 4. And now I'm going to lazy check. What I'm going to do is I'm just going to take the number 4, plug it in for that x, and I'm virtually calculator check to save time. So I'm going to go 5 times 4 plus 18. That's taking 4, plugging it into the original problem. My answer is only correct is when I hit equals. I get 38, and I do. So this is without writing down. I still checked it. And that's kind of what I would encourage you to do. Of course, if you get a mistake, then maybe you need to start writing stuff down. But for now, I can speed up the process, make the lecture go just a little bit quicker, and hopefully not make it any more confusing by doing that checking. So 24 is a blended problem too. It has a number multiplied by the variable, a number subtracted. I need to do the adding and subtracting first. If a number is subtracted, we add it. So I'm going to add 20 to both sides. I don't need my calculator to add 40 and 20. On the left-hand side, the 20s cancel. Similarly, I don't need my calculator to do the division part of this. So first I isolate, I get the constants by themselves, and then I divide or multiply if I had a fraction coefficient to get the variable isolated. So it's just 2 steps, exactly the steps we've been using. And calculator check, virtual, so 6 times 10 minus 20. That's just taking that z, changing it to 10. The right-hand side is 40. If when I hit equals, I get 40 back, my answer is right, so my answer is right. So I can put a check that I checked it, even though I didn't really write down what you might want to write down. But again, you don't have to. Checking is just for your assurance. 26, still the same 2 steps. I need to undo the addition or subtraction first. In this case, I'm going to subtract from both sides. And 21 minus 15, I can do without a calculator. It's 6, but I don't care if you're using a calculator for things that, some students can do in their head. Now, instead of dividing by 3/4, I'm going to multiply by the reciprocal, which is 4/3. On the left-hand side, if you multiply a number times its reciprocal, you get 1. We don't need to write that 1. And on the right-hand side, I can do this in my head almost faster than my calculator. I'll cancel that 3 with that 6. This 3 becomes that 6 becomes a 2, the 3 becomes a 1. Fraction is gone because there's just a 1 in the denominator. I believe the answer is y equal to 8. Let me show you this multiplication of 6 times 4/3 real quickly. So 6 times 4/3 using a parentheses for the times as opposed to a times sign. But I could have used times signs as well. I could have done 6 times 4/3. Doesn't matter. I get 8 for an answer. And now I'm going to speed check. So fraction 3/4. Move over, then either use a parentheses or a times sign, but change that y to an 8. So either left and right parentheses with an 8 inside or a times 8. They work the same. Plus 15. When I hit equals, I better get 21 because the left-hand side needs to match the right side, and the right side's already 21. So I checked that just fine. You'll notice that most of my answers are nice-ish numbers. Every now and then I sneak in a fraction answer just because they can be fractions. So you should be, prepared for fractions, but I try to keep things, clean for most of the time. 28, exactly the same strategy. I needed to get rid of the subtracting first. The opposite of subtracting is adding. On the left-hand side, I cancel out the -5 with the +5. And on the right-hand side, if you can't do -11 plus 5 and get that -6, it's okay. You can do it on your calculator. And now I'm going to multiply by the reciprocal. I'm going to put the negative in the numerator as opposed to in the denominator. On the left-hand side, multiplying by reciprocals, you get 1. On the right-hand side, if I want to by hand do this, I'm going to cancel this -6 with that 3. 3 divided by 3 is 1. Fraction is gone. -6 divided by 3 is -2. That leaves me with -2 times -2, which I think is 4. On the right-hand side, I could have just done -6 times fraction -2/3 to get that 4 as well. I believe that's the answer. Always should check. So I'm going to check right here. I'm going to put my -3/2 first, and then either with a times sign or with a parentheses, times 4 minus 5. I best get -11 when I hit equals because that's what the right side already is. And I did, so I'll put a little check mark down. "30 I wrote backwards." You don't have to have the letter or the variable on the left-hand side. Most students like to have the letter or the variable on the left-hand side, but it doesn't matter. And anytime you're given an equation, if you don't like how it's written, you'd rather the left side be on the right-hand side, equality is commutative. So I can just rewrite this problem to make it more comfortable for me. This equation is going to have exactly the same solution as the top equation. Now it looks normal to me. That's completely legal to do for any time you have a problem with an equal sign. Just flip-flop it without changing any signs completely. You'll still get the same answer. Now let me solve this, which I think is just less awkward to solve. So I subtracted 40. And then 28 minus 40, I believe, is -12. Completely well worth your time to do everything on the calculator unless you're just super confident in your ability to do the math in your head. So I subtracted, then I divided. I better check in this one. So in this one, I'm going to go, is 28 equal to 2 times -6 plus 40? Just in case I made some sort of careless mistake when I was, sometimes I'll copy a problem down and I'll copy it wrong. That'll guaranteed happen before the semester ends, more times than I should. But I'm just going to enter the answer in the original problem. And when I did that, I get match. And so I know I've perfectly checked. Wouldn't have to write that down either. Same issue with 32, or with 32 has a 32 in it. If you don't like that the variables on the left-hand side are on the opposite side that I'm used to, I can flip-flop it. Eventually, we're going to get to the point where this will be silly to do, but now we're just learning how to solve these equations. This is okay. So I'm going to minus 15 and divide by 4. I'm going to get a fraction answer, a negative fraction at that. So on my right-hand side, I have negative 32 minus 15. I'm going to get negative 47. I'm going to divide both sides by 4. And I'm going to get x equals negative 47 over 4. And I'm going to check right up here into the original just in case I made some mistake transposing something. It just can happen. So I'm going to see if negative 32 equals 4 times negative 47 over 4 plus 15. I already have the one side, so I'm just going to work on the other. I'm going to go 4 times parentheses fraction negative 47 over 4. The 4's would just cancel there, plus 15. And that would give me negative 32. For this checking, these 4's would just cancel, fraction would be gone, and on the right-hand side I'd have negative 47 plus 15, and that is negative 32. That negative 47 plus 15 that the right side would simplify to is just what I need it to be. Again, I still have the variable on the side that I'm not comfortable with, so let me just rewrite this as 3/4 x minus 1 equals 14. Same two steps that we've been doing. I'm going to get rid of the subtraction first by adding 1 to both sides. And because the coefficient is a fraction, I'm going to multiply by the reciprocal of the coefficient. Could use my calculator on both sides, but on the left-hand side that's absolutely silly. A number times its reciprocal is 1. And on the right-hand side, I can easily do this by hand. 3 divided by 3 is 1. 15 divided by 3 is 5. Cancels the fraction. Leaves me 4 times 5, which is 20. Believe that's the answer. Again, I'll never know if you just press buttons. If you did 4/3 times 15 on your calculator, got 20 for an answer, that's completely fine. If I wanted to check, I probably wouldn't write down anything, but I'd go to the very original problem and see if 3/4 times 20, either with a parenthesis or a times sign, minus 1 makes both sides equal the same number. The left-hand side started off at 14. When I plugged 20 into the right-hand side, I got 14, so I know my answer is correct. Hopefully this feels like too many problems. Sometimes when I, help students, I don't give them enough problems, and I'd rather give you too many just to make it so it's like boring now. It's like, oh, I can do these. These are easy, especially with a calculator. Hopefully get to that place. So I flip-flopped 36. I'm going to minus 10, minus 10. Notice I'm not really saying the steps like I wrote up front. I just kind of know how to solve these at some point. Once I get the left-hand side to be a number times the variable, I either divide by that number. If the number is an integer, I multiply by the reciprocal. If the number is a fraction. And really easy to multiply on the right-hand side without my calculator. I can think of this as 3/1 times 3/4, multiply across the 3's, multiply across the 1 and 4. The answer should be 9/4. What I did when I had 3 times 3/4, which I needed to do, I could do that multiplication on either side and it just fit on the right-hand side. I wrote the 3 as a fraction, multiplied across the top, multiplied across the bottom. But I could have just done 3 times fraction 3/4 to get my 9/4. Let me check up here, right in that part right there. I'm going to go fraction 4/3 times fraction 9/4 plus 10. That's plugging in 9/4 for that y, and when I hit equals, I better get 13, otherwise my answer's wrong. And I perfectly got 13, so I know my answer is correct. A few more, and then we're going to go into a part 3. Now it doesn't make as much sense to flip-flop this, because if I flip-flop 38, well, it's not doing me any good because I have variables on both sides. When you get variables on both sides, like I have here, I've got 2 separate y's, I need to pick a side and get the variables on them. And students always want to have the variables on the left-hand side. It's okay to have the variables on the right-hand side, and it'll take less steps. So I need to gather the 2 y terms on the same side of the equation. It makes more sense to get them on the right-hand side of the equation because my goal is to get the variables on one side, the constants on the other side, and then divide. In this particular problem, if I get the variables on one side and pick that side to be the right side, my work will be less. Now we have like terms on the left-hand side. This 10y minus 14y, I can't do the y's on my calculator, but when we're adding and subtracting with like terms, meaning the same variable with the same exponents, when I'm adding or subtracting, only the coefficient, the number before the letter, changes. So 10y minus 14y is just negative 4y. Now I kind of have reversed what I'm used to. I have the letter on the right-hand side, which I'm just going to deal with. It's multiplied by the number negative 4. I'm just going to divide both sides by negative 4. On the left-hand side, I'm going to do 24 divided by negative 4, and that will give me negative 6. On the right-hand side, you just get 1. Negative 4 divided by 4 is positive 1. I claim that's my answer, and I have to double check because the original problem had y's on both sides of the equal sign. I can't just do a single check. What I need to do to check is change both y's in the problem to negative 6. Simplify the left side, 14 times negative 6 plus 24, and get negative 60. Simplify the right side, 10 times negative 6, and my answer is only correct if the sides come out to the same number. Again, it doesn't matter what number I get, just as long as the number is the same. Getting to the point where I need to probably break this because it's pushing 30 minutes. I don't like to get much longer than that. So, yes, 1, 2, 3 problems quickly, then we'll do a part 3. So on 40, I'm not going to mind getting the variable on the left-hand side because this is set up so that in one step, I can make it to have the variables on one side, the constant on the other. On the left-hand side, when I subtracted 2z, I left myself with a minus 24. And on the right-hand side, I have minus 6, using the minus by the fraction, negative 6 minus 2. The number in front of the z is going to be negative 8. Now I'm going to divide by negative 8, divide by negative 8. I could use my calculator, but I'm trying to speed this up. I'm going to say this gives me 3 equals to z, and I have to check on both sides. I can't get off just checking one side, so I need to go 2 times 3 minus 24. Does that equal negative 6 times 3? Checking on the left side, 2 times 3 minus 24. I get negative 18. Checking on the right side, negative 6 times 3, I get negative 18. So I know my answer is correct. I could still virtually check that. It's not the case that I have to check it with my writing stuff down. On 42, I'm going to wind up getting the variable on the left-hand side, because if I have this kind of set up where one of the sides has a constant, I want to get the variables on the side that doesn't have the number without the letter. So I'm going to minus 13x from both sides and get to a common trick. On the right-hand side, the 13x's cancel, leaves me with a minus 15. And on the left-hand side, I'm doing 12 minus 13. I like to write the -1 in front of the x. If the coefficient is supposed to be a -1, I prefer to write it because now I know what to divide by. Now I'm going to divide both sides by a -1. On the left-hand side, the -1's cancel to become a positive, and on the right-hand side, negative divided by negative is a positive. Let's speed check this. I'm going to see if 12 times 15 equals to 13 times 15 minus 15. So left-hand side, 12 times 15, which is 180. Right-hand side, 13 times 15 minus 15, 180. I know my answer is correct. So one more, and then we'll do a part 3, which I kind of expected the whole time anyways. So 44, structurally the same. I'm going to get the letters on the left-hand side, or the variables on the left-hand side, because I want to get the variables separated from the constant. So the side that the constant was on is the opposite side that the letter is going to come on. On the left-hand side, 33 minus 8 is 25. I leave the y. On the right-hand side, I cancel out the 8's, and I'm going to get a fraction answer. I'm going to divide by 25. I'm going to get y equals to 49 over 25. If my calculator wasn't so fraction friendly, I'd probably forget about checking, especially because this video is getting so long, but I can check super fast and start the part 3. So I'm going to go to the original problem. Change both y's to 49 over 25. Left-hand side, 33 times fraction 49 over 25. Left-hand side comes out to 1617 over 25, of course. Right-hand side, 8 times 49 over 25 plus 49. And I get that same 1617 over 25. I know my answer is right. I'm going to pause and do a part 3.